Hello everyone, my name is Jared Casillas, and I'm going to be telling you about how remote sensing and non-invasive archaeology have truly changed and impacted the ways that archaeologists discover, document, and come to a deeper understanding of our ancient civilizations. I will tell you about several amazing technologies and give you an example from the Maya city of Ceibal in Guatemala that shows why these technologies are so useful. Before the development of these technologies, archaeologists mostly relied on traditional field surveys to locate archaeological sites, along with talking to native populations in the area. These traditional surveys required massive amounts of time, money, and manpower, and most of the time, archaeological remains actually stayed hidden because they were buried underground or even covered in dense vegetation. But today, because of these amazing technologies, archaeologists can use these powerful remote sensing technologies to investigate these sites without damaging them and at much less cost. Ground penetrating radar is one of these technologies and has the ability to detect buried features below the surface. Geographic information systems serve different purposes. They organize, catalog, and analyze all the archaeological data gathered, while LiDAR reveals different landscapes that are hidden beneath dense foliage and forests, giving archaeologists a much more in-depth and easily accessible wealth of knowledge to explore. Remote sensing uses many different technologies that each have a specific purpose. Ground-penetrating radar sends radar waves into the actual ground and then records the reflected signals. This gives archaeologists data that is then used to create a three-dimensional image of any buried ruins, like walls, floors, graves, or other important archaeological features, without any major excavation actually being necessary. Geographic information systems take all the data that is found, organize it, analyze it, and then give it to archaeologists so that they have the ability to map sites accurately and find any settlement patterns or relationships between different ruins that are identifiable across the landscape that they are surveying. LiDAR, on the other hand, works a little bit differently. Instead of looking underground, this technology uses drones to create a very detailed map of the ground surface by actually digitally removing dense foliage that would have covered ruins and revealing ancient buildings, city layouts, roads, or even sometimes entire settlements that would have otherwise remained hidden beneath this foliage. One of my favorite examples that I stumbled upon during my research was the Maya city of Ceibal in Guatemala. While researching this city, archaeologists used airborne LiDAR to survey approximately 470 square kilometers of the Mayan lowlands. During that archaeological survey, they were able to identify more than 10,000 archaeological features, like ruined structures, settlement groups, human-made modifications to the landscape, and even roads that were hidden beneath dense forest foliage. What made me truly interested in this study, and why I think it is so important, is that it really shows how LiDAR, while being an amazing technology that greatly helps archaeologists in the study, still works best when is combined with traditional archaeological surveying. These technologies are not meant to replace traditional archaeology, but instead bolster it and make it cheaper and easier to study these archaeological sites so that more and more discoveries can be made every year. These technologies help archaeologists to identify features and then, through traditional fieldwork, give a deeper understanding of what they are analyzing. Some of the traditional fieldwork that they might do would be field surveys, ceramic analysis, architectural analysis, pottery design analysis, and excavation. This allowed the archaeologists in the study to actually reconstruct how Mayan settlements and society changed overall from about 1000 BC to 950 AD. Not only that, but additional research clearly showed that drone-mounted LiDAR is very cost-effective and efficient at documenting ancient ruined settlements and the land around them, while also causing little to no damage as opposed to traditional fieldwork. Over the course of this presentation, I hope you've learned more about remote sensing technologies and how they help save time, reduce costs, protect archaeological sites, and help archaeologists gain a much deeper understanding of past civilizations. Most importantly, they are not meant to replace traditional archaeology, but instead work in tandem and alongside with it. I hope this presentation gave you a small look into the future of archaeology. Thank you for your time.